Okay, let's review what we've done so far in 3.11. 3.11 is differentials. Remember, this is the last section. It'll be on the upcoming test. Before we go today, we'll vote on when you want to do the test, whether you want to do it Wednesday of this week or wait until Monday of next week to take it. So an increment, remember, is a final value minus an initial value. Delta means a change in the value. dy is a differential. dy is the change in y that happens as we start at x and travel along the tangent line. dx is a differential. Together, dy over dx is the derivative. But here we're looking at separate meanings for dy separated from dx. Had a formula for dy. dy is the derivative times dx. dy and delta y are close in value, but not exactly the same. The formula for delta y, the only other formula you need to know in this section is delta y is f of x plus delta x minus f of x. Sometimes that x is called a or x0. It's just the starting x value. So delta y is the true change that happens as we begin at x and stay on the curve, stay on the graph. So dy will give us an approximation for delta y. Delta y is the true value, dy is an approximation. We worked some problems where we found the values. We found the error by subtracting the two. Then we had a couple of problems where we wrote formulas. I can't remember if on 46 they gave us that formula. I think they did, didn't they? B equals x cubed. Yeah, they gave us the formula for that. So we found the differential dv, so we found the derivative and multiplied it by dx. And then right before we left, this one was a little more complicated. R was changing, so R was the variable. So we had to use the product rule because we had an R out here, had an R in here. And so to get the derivative, to get this thing, we used the product rule. And then we multiplied it by d, in this case dr, because r was our variable. So dy in this case was ds. That took the place of y. In our problem, instead of dx, we had a dr because r was changing. R was the variable. So the variables may change, y and x, but the idea of this formula is not going to change if it says find a differential formula. Now let's do one more of these then. Number 50, page 211. The change in the lateral surface area, S equals 2 pi r h, of a right circular cylinder when the height changes from h0 to h0 plus dh and the radius does not change. So when I say radius does not change, let's just say radius is constant. So it's good to have all your constants out front. Now S is a variable because it's taking the place of normally y. Usually it's y equals some x stuff, right? So S is a variable. 2 is definitely a constant. Pi is a number. It's a constant. H is changing, so it's already in a good order. H is my variable and it's already at the end. So I'm going to put my 2 pi r in front and kind of tack my h onto the end there. Kind of help my brain remember that 2 pi r is all number stuff. Alright, so we're ready for our formula. Directions again up at the top of that section. The problem said write a differential formula. So anytime they ask for that, they're asking for dy equals f prime of x dx. So in our case, we need a ds. ds equals the derivative of This is a number, right? So if I had just a 7 out there, wouldn't I just ignore it? So I write 7. Oh, that's representing my constant. So I don't do anything with the r. I don't do the product rule. I don't bring a 1 down and subtract 1. R is a number. That's my only variable. The derivative of h is 1. That's that part. Times d, whatever the variable was. My variable was h. So dh. So my final answer for my differential formula is ds equals 2 pi r dh. Any problems with number 50 before we do another one? All right, let's look at page 206. This is kind of a lengthy problem. It has 3 parts. Example 6. A part is use dA to estimate. Now, if ever 2 words or terms went together, it would be a dA, because a d something is a differential. And aren't differentials estimates? Right? It's the deltas that are the true values, but it's the d whatevers that are the estimates. Like a dy would be an estimate. So an estimate, and then right 2 words later they have the word estimate. So those really go together. Use dA to estimate as if we could do much else with it. To estimate the increase in the circle's area A. We'll wait about B part. And C part. Alright, what did they give us then on this one? The radius of a circle, the radius r of a circle increases from A equals 10 meters to 10.1 meters. Now let's draw a circle first. Instead of using A for the radius, let's use R. So the radius is 10, and then the radius is 10.1 meters. So the change in the radius was 0.1 meters, right? Or is just a value for R. 10. The new total was 10.1, but the difference was 0.1. It increased by a little bit. So if we went out a little bit more, say a tenth, and we could draw another circle, it looks something like that, wouldn't it? The new one would be much closer to the original than the way I'm drawing it, but I'm not able to get it a tenth of a unit away and make it look like another circle. So that little distance there is a tenth of a meter. Let's see what else they tell us. Use dA to estimate the increase in the circle's area. That's A part. I've called it A part. They don't have A, B, C in the book, but they have 3 parts, 3 questions they're asking us. Let's start out with a formula. Now, last time we met, I said that this section had some problems where they give you the formula and some where you have to remember the formula. So now we're getting into the ones where they don't come right out and tell you, use this formula. So what did they tell us on the last problem? They said, here's a formula, right? What about the one before that? Here's a formula. And before that, here's a formula. Okay, now then we're coming up with our own formula. It's some of those same formulas they gave us before, but we got to decide which one to use. All right, we're talking about area. Area of a circle. So what's the formula to find the area of a circle? I times the radius squared. Right? Okay. Well, now then that's just as if they gave it to us. Now it's just like the other formula problems where they gave us the formula. It's just you've got to come up with what to start out with. So let's think about it now. We've got an A, looks like a variable. Pi is a number, and R is a variable. Got 2 variables, right? They want us to find dA. So before we find dA, let's write our formula for dy. What's the formula for dy? F prime of x times dx. dy f prime of x times dx. dA f prime of r dr for our problem. So for us, dA instead of dy equals the derivative. We need the derivative of that, so we're going to bring our 2 down, 2 pi r to the first. So 2 pi r is the derivative. Times dx, not x, but for us a what? Independent variables, not a x, but a r, right? Times dr. So a and y, r and x. Alright, so now there's our formula, and we just got to put our numbers in. So dA is 2 times pi times r, here's r, times 10 times dr, here's dr. We had to subtract to get dr. We don't want to use 10.1, which is a common mistake. And it says, well, the change in r is 10.1. No, the change was only 0.1 because we started out at 10. So dr is 0.1. 0.1 is really a tenth. So 1/10 times 10, those would cancel, and that would leave me with 2 pi. 2 pi, and I don't know if they gave us units on that. Meters or anything like that. Meters. An area would be a square unit. So 2 pi square meters, or meters squared. So that's the estimated increase in the circle's area. So if our circle increased from a radius of 10 to 10.1, then we could say that the area, approximately the area inside the circle would increase by 2 pi. Pi is about 3.14, so 2 times 3.14 would be about 6.28. So we would have about 6.28 more square meters in this extra little part than we had to start with. That's not the total amount of area, it's just the increase in A, the change in A. Alright, B part. B part's the longest part of this one. Estimate the area of the enlarged circle. Estimate the area of the enlarged circle and compare it to the true area. So you've got a picture in your mind of those two circles, okay? You want to estimate. Now, if we're going to estimate, are we going to use deltas or are we going to use d's? Which one is the estimate? The d something, right? So what we're going to do is start out. It also asks about a true area. We're going to start out with the delta formula and change it into a d formula. So delta y, let's start out with delta y. It equals f of x plus delta x minus f of x. Now we can't stay with that because for the same reason y'all said, okay, we got to use d's because it said to estimate. We're going to change some of the deltas into d's in a minute, but let's regroup. Let's get this one over here with this one. So that's going to give me a f of x plus a delta y equals f of x plus delta x. And then the book wants to put this one first, so we'll do it the way they did it. F of x plus delta x. And they've got that one next. So they switch places with these over here and they write it in this order. So it's the same thing, I've just rearranged it. All right, now then if we're going to estimate, we're going to change these deltas. Both deltas we're going to change into d's. Now does anybody remember what we said about delta x and dx? They're exactly the same, aren't they? So rewriting that as that didn't change the fact that it's still a true value because they're the same anyway. They're always equal. But this delta y, turning it into a dy, is really where that word estimate is going to come into play. Because delta y and dy are approximately equal, right? But delta x and dx are exactly equal. Alright, now then, one more change, then we'll put our values in. We don't have an x in our problem, we have a r. Remember here, instead of x, I said we're going to use r. Instead of a y, we're going to use a. I don't know that we have any of those, but so let's make our x's r for radius. Yeah, here's a y, so that's going to be a dA plus f of what? R, right? So radius is our x. Now, flipping back to the screen or looking back in your notes, r is 10, dr is 0.1. And look at A part's answer. We're going to need that answer, 2 pi, to put in for dA. So r is 10, dr is 0.1, 1/10. dA was the answer to A part, 2 pi. F of r would be f of 10. Yep, so r is 10. So f of 10.1 is 2 pi plus, I'm going to put 10 into the function and see what we get. So this is the function, this is the original. If you put 10 in and square it, what's 10 squared? 100. So it's going to be 100 pi, isn't it? Just a function of 10 doesn't mean use a derivative or a differential. It just means go to your original. (102 pi), estimate the area, so that would be square meters also. Estimate the area. Okay, and then C part. And the B part had another part. B part said estimate it and compare it to the true area. So the true area the new circle had a new radius of 10.1. So do that on your calculator, 10.1 squared. Or do it on paper. And then just leave the pi in there. Don't multiply out the pi. Okay, what's 10.1 squared going to make? Okay. And then the pi wasn't squared, so we'll tack it on there. Square meters. So that's the true area of the new circle. So the estimate of the area is what we got here because we used dy instead of delta y. Okay, so 102 pi is an estimate. The exact true area would be this. C part says find the error. Find the error in your estimate. So the error would be, they don't give you a formula for that. It's just these two answers subtracted. So I'm going to start with the first one I got, 102 pi, minus the one I got last, 102.01. When I subtract those, I forgot my pi there. So I'm going to get a negative 0.01 pi. It's like if you had 7x minus 8x, you'd still have a negative x. You wouldn't just have the negative 1, would you? So you still got the pi there with it. And so the positive of that is 0.01. They leave it like that. They don't try to make it into a decimal by multiplying out the pi. So you see the purpose of those absolute value bars? You could have started with that one and then subtracted that one. You get positive 0.01 pi. Still going to make it positive either way. So all you care about on the error is how far apart are they. You don't really care which one's larger or which one's smaller. Now that's the toughest one, I would say, in the whole lesson. It had so many parts, especially B part. Okay, let's look at a few notes here on page 208. Very top of the page. Sensitivity to change. The equation df, or dy, equals f prime of x dx tells how sensitive the output of the function is to a change in the input at different values of x. The larger the value of the derivative at x, the greater the effect of the given change dx. As we move from a to a nearby point, a plus dx, we can describe the change in the function in three ways. In your book, circle the word true in that column. True change. Mark out the delta f and write a delta y there. Delta y is a true change, and it's equal to f. Mark out the a and write an x. F of x plus dx minus f of x. Mark out the dx and write delta x also. So absolute change, after you mark everything out, should be delta y equals f of x plus delta x minus f of x. It's the same thing they've got, but we're used to using x instead of a for our beginning value. All right, on the estimated, mark out df and write dy equals f prime of x dx. dy equals f prime of x dx. The a's are just saying they're going to give you a number, a specific value to put in. That's all that a is about. All right, relative change, delta f over f of x again. Change your a into an x. And then estimated column, df over f of x. Okay, percentage change, delta f over f of x times 100. You're just making the answer right above it a percent by multiplying it by 100. If you had 0.25, you wanted to make it a percent, wouldn't you do that? So that's what the third column, the percentage change, the third row is all about. And then the estimated change, df over, I would just say f on bottom. df over f, or df over f of x times 100 to make it a percent. The big thing you need to see from that chart is that true changes involve the delta y and estimated changes involve the dy. I don't think you have any problems where it specifically asks you to find one of those values. Let's do one more problem from this lesson, and that'll finish it up. 52, page 211. Somebody in group 4, read that one for us, please.
The diameter of a tree was 10 inches. During the following year, there was circumference increased to about how much did the tree's diameter increase? The tree's cross-section area.
So A part, how much did the tree's diameter increase? What? Okay. Going to have to label all of our values, aren't we? B, the tree's cross-section area. Let's see what other numbers that give us. Diameter was 10, so D equals 10. Let's draw a circle here. Here's the center. So the diameter is 10. Now that's a little different from the one we did a minute ago. A minute ago they gave us the what? Radius. So if the diameter is 10, what's the radius? 5. That's probably going to help us more. to know the radius. The diameter of the tree was 10, so the radius was 5. During the following year, the circumference increased 2 inches. So that's a DC. The change in the circumference was 2 inches. Okay, and that's like if you took a tape measure and you wound it around the tree. Right? You said, okay, and a year later, was it a year later? However long, much time passed. During the following year, you did the same thing and the circumference was 2 inches more. So that's a change in C, the distance around it. It's not a change in the radius or a diameter like the last one where we said that this was 0.1. We don't know what this is this time. Let's just write down formulas we know for circles. Area, we just did that one, didn't we? R squared, but they mentioned circumference this time too, so that's probably going to be important. So the circumference of a circle, there's 2 formulas for it. Anybody remember one of them? Group 3, what do y'all think? Circumference of a circle. Two times group 2, what do you think? Okay, that's close. Group 1, what do y'all think? 2 power. Okay, C is 2 power. Or you could also use C equals pi d because 2 r's make a d. So whatever the radius is, that's just doubling it. 2 r's make a d. So we're going to use this one for 2 power. All right, looks like maybe we need both. I don't know. Why didn't they just cut the tree down and check the diameter then and see how much it had increased by? You just killed the tree, right? So they wanted to try to determine the important changes in the tree's circumference and diameter without actually cutting the tree down. All right, A equals pi r squared. How much did the tree's diameter increase? If we can figure out how much the radius increased, then we can just double that to figure out what the diameter did. Do we know an area? Or we don't need that one. All right, let's go over here to C. C equals 2 pi r. Change in C is 2. We can't put that in anywhere because that's not just a C, is it? R is 5. All right, let's go over to this formula. If we found the formula for dy, the differential, it would be the derivative times dx. We may not need it, but let's just find it anyway because we've already done it today. Derivative of A is 1, and it's dA. A is taking the place of y. So dA is my differential. The derivative of this side is going to be 2 pi r. It's this part. Times dr. Okay, so 2 pi r. Do we know what r is? It's 5, isn't it? Do we know what dr is? They don't give us dr, do they? So this formula here looks like it's leading us to a dead end. We don't know what dA is, and we don't know what dr is. So we got 2 unknowns. Let's try this side. We can't put 2 in for C because this is a DC. It's a change in the circumference. It didn't say the total circumference of the tree was 2 inches. It said the change, or that it had increased by 2 the following year. So here, DC, just like dy, would be the derivative of that. What's the derivative of that? 2 pi. And then times dx, or in our case, dr. So dc is given to us, so let's put the value in for it. So dc is 2. We've got an unknown. dr is our unknown. And it's sort of what we're looking for, because we're looking for a change in the diameter, but if we can get a change in the radius and then we can just double it, we'll be in good shape, won't we? So let's divide both sides by 2 pi. So 1 over pi equals dr. How much did the diameter increase? If you want to know a change in diameter and you've got a change in the radius, you just double it. So 2 times that. So I guess we could call it a DD, a change in the diameter. So 2 over pi. And on the units, inches. Squeeze in a little IN right there. Okay, so this really helped us absolutely none whatsoever. But it made us feel a little bit better because we knew how to find the derivative of area equals pi r squared, didn't we? So if you wind up with 2 variables, you know, you're stuck. If they don't give you a value for one of them, but here we wound up with 1 variable because we had a value for this variable. And we were able to solve for dr, double it to get the change in the diameter. Now it asks about the area. Okay, now maybe we can go back and use some of that. I'm glad I didn't erase it. So let's go back to dA, since we've already found it. If we hadn't already found it, we'd be starting right here at the top and finding the derivative. So dA is 2 pi r dr. Wants to know how the area changed, so that's what we're looking for. We need an r value. Do we know an r value? R is 5, yes. Do we know a dr value? Because dr is together a variable, isn't it? It's dr. 2 over pi? 1 over pi is dr. 1 over pi is dr. Don't fall into the trap of saying, okay, well, I need the answer to a part, so I'm just going to throw a 2 over pi in right there. Got to think about what the variables mean. That says dr, that's not a dr, is it? That's a change in diameter. So the pi's cancel. So I've got 5 times 2, I got 10 left over. So the change in the area is 10 square inches. So without chopping down the tree with a chainsaw, a year later we can go out there and measure the circumference of the tree. It's 2 inches more than it was, right? And based on that value, and knowing that the original radius was 5, we can get a change in the area. Now, even if you didn't know a radius, just totally outside of this problem, if you went out and measured the circumference of the tree, you could put that in here, divide whatever the circumference is by 2 pi, and then you can get the radius of the tree without having to cut the tree down, right? For any given circle. So there's the change in the diameter, and there's the change in the area. That finishes up 3.11. All right, that's a tough section. So we're ready to vote? We'll vote now, or you're going to wait until after the break? Let's vote now. You all look like you've made up your minds. I have a feeling, I'm sure, what 98.75% of the class will want to do. Those who are absent, I can't speak for them. But who would like to take the test up to this point, 3.11, on Wednesday of this week? Raise your hand. That's what I thought. Monday of next week, raise your hand. Okay. Some didn't vote at all. You're holding out for next 4th of July, but can't wait that long. Gotta get it over with.